All right, graphing. I know how much you love it, so it's been a while, so let's make sure that we get some of this. You did it in 9.1, 9.2, 9.3. Now we've waited so long. Oh man, has it been like 9 sections? Oh, I miss it so much. Right? These ones are going to be square root functions. So the first thing they're going to ask you to do is about the domain. You remember that word? That word represents the x-axis. And basically what we're doing is we're dealing with the stuff underneath the radical. That's what we want to consider. And the rule of thumb here, remember, is that the square root cannot contain a negative number. So that means that 3x minus 9 must be greater than or equal to 0. Since it can't be negative, it has to either be 0 or a positive number. So all we do is we take what's under the radical and we say that it has to be bigger than or equal to 0. That is the domain. Poof. Isn't it incredible? Completely incredible. All right, so moving on. Practice. Graphing. Okay, sorry, I'm going to stop that. We want to graph y is equal to the square root of x. All right, so we're going to make a table. Picking some numbers of, pick some numbers. I'm going to pick some ones that are easy. All right, so 0, 0, by the square root of 0 is equal to 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So we draw a coordinate plane, perfectly straight lines. 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. So I got 0, 0, 1, 1, 4, 2, 9, 3. This is what it looks like. Let me keep going like that. It's basically, these are going to look like this sort of a graph, because they can't go below here. Y will never be negative, so as long as this is what's called the parent function, this is the most basic function that we can graph, it's going to go up and it's going to continue to grow and grow, but it's going to get more separated on the x-axis as it gets separated on the y. Okay? So table, graph. Now, it is possible to move it up or down. Going back to the graph, the table that we had just made, I picked 0, 1, 4, and 9. Now I get 0 plus 2, so this is added 2. I get 1 plus 2, that's 3. I get 2 plus 2, I get 4. And I get 3 plus 2, and I get 5. So all this is going to do is shift it up. So now I have 0 and 2, 1 and 3, 4 and 4, and 9 and 5. So all that did was it shifted the graph up. So now it's going to look like that. So when we add a number or we subtract a number, if we subtract it, we're going to move it down. If we add it up, outside of the square root, that shifts it vertically. So I wonder what happens if we put it inside the square root. Let me push the next slide. Oh, there it is. It's called a horizontal translation. So now we look at x and y. This time we're dealing with the process of adding. So I'm going to kind of think of some other numbers. Let's say I pick a 1. No, let me do this. I'm going to do negative 3. So if I pick negative 3, I'm going to get 0. Alright. If I pick negative 2, I'm going to get a 1. If I pick a 1, I'm going to get a 2. And if I pick a 6, I'm going to get a 3. So I can manipulate the numbers a little bit. because I know what perfect squares I want. So whatever I want underneath here, I'm then gonna try and do what I can to get it. So, all right. So then we graph it. So -3, 0. -2, 1. 1, 2, and 6, 3. So you notice that it's the same graph, except now we've just shifted it left. So with a +3, we're going to shift it left. If it were a minus, we would shift it right. All right? And then it is possible to do all of those. Not quite what it's here, but you can graph those too. Just to show you, we could do this. Y is equal to the square root of x plus 6 minus 3. All right. That would add both. So we're going to shift it 3 down and 6 left. So the point's going to be there and so on. Okay. So check them. See how you did when you come to class.